Good morning. In the last class, we had discussed about some of the part modeling exercise in the cryo elements. Today, we will conclude by seeing one more exercises, and then we'll finish off the components that are left in the fifth unit. So now, again, same. If you go to New, select the part, click the solid, and then click OK by entering the name of the part on which you want to save. Then you need to choose the template as mmns underscore part underscore solid. Then you can write the name who is modeling it, and also the description of the part which you are modeling. So then we'll go up to the 3D environment, part environment, and then here we are discussing about the last exercise, that is this part modeling. So basically it can be done in many ways, but here the best way or the simplest way is that I can take the right plane and I'll draw this profile, that is 50 length and then 75 height and then this height, that is 12, and then I'll join this and then I will extrude it to 63. So that will be my first block, and then after that block I'll use cut this section and just cut that section. See, the right plane I'm selecting, and I'm going to the sketch environment, and then I'll just draw the profile. See, general profile I have drawn, and then I'll mention the required dimensions over here. So it is 75, 50 and 12. 75, great, 50, great. Oh, the line has been blown. So 50, okay, then 12. That we have drawn, and then click OK. It will come out of the part environment, and how much you want to extrude, but you want to extrude on either side of the plane. See, because we want it to symmetric, hence either side of a plane we want, hence you select either side of the plane over there, and then the dimension is 63. Now the first block is created. Then I am going to cut this section by using the plane on the bottom surface of the block. So the rectangle must be 25 mm away and 12 mm width, and from that there was certain distance. Just I'll choose that plane and then I'll sketch, and the part will be oriented. Here I need to draw because this is the profile and it comes over here, so I need to draw it a rectangle over here. So but for that I need to invoke this reference lines, or else just and then draw the rectangle and then mention the required dimension, that is 12 height, and this dimension and this dimension edges with respect to the sides are given. It is 25 from that side, and from this side it is 25. So the part is done now. Click OK and then change the direction and then use cut material, or you can say up to next, up to all, extrude through all, and then use cut material or remove material, then click OK. So the second feature is done now. Then for this feature also I'm going to use this plane, and then I'm going to cut it to the required length. See, this plane, then sketch orientation, so the plane is oriented normal, and then I'm going to invoke the reference lines by clicking on the reference. Then draw the profile, that is nothing but the rectangle. The required dimensions I need to draw. This dimension, also the dimension is 12. and then click OK, and then extrude in the change the direction. Up extrude to all the surfaces you click, and then remove material you click this. OK, then this feature is remaining now. So then I choose the central plane. I'll just draw the profile on that line with required dimensions, and then I'll use the extrude command to extrude on either side of the plane. Close the profile and then dimension it. That is 12, height is 16, 12, height is 16, and length is 25, and then you need to extrude it on either side of the plane. So for that, select on either side of the plane, click, and then the dimension up to which length it needs to be extruded on 25. So this is how the part is done. So before this, you might have used the other modeling softwares, but once you have a look at the Creo Elements, you feel that Creo Elements is much more easier compared to the other softwares with respect to part modeling. Even before joining into the industry people were used to use the Creo Elements itself. Back then in 2012, our industry was using this Creo Elements. But before that, I used to practice all my MTech drawings in CATIA and Pro-V. But once I started using Creo Elements, it was much more easier and much more fun, because there was no need to constrain the sketches. Then there are a number of commands which makes the designer more flexible to draw more complex drawings. Hence, I felt the Creo Elements was much more easier and consumes less time to draw the part when compared to the other modeling softwares. Next, we'll start with the 5th unit, quality by design. As defined by Webb, design as the set of process that translated customer requirements into manufacturable outcomes. Is that true? So what is the design? What is the design? It is nothing but the set of processes that translate the customer requirements into manufacturable outcomes. So if I want to produce this cell phone, so there must be a market survey, and there had to be customer requirements. Once you satisfy the customer requirements only, then the customer is going to buy this. So, but I want to satisfy the customer requirements. I know what is the customer requirement for a particular cell phone. I want to satisfy the customer requirement by producing this part, but I can't say directly produce this part in one process or two processes or in one step or two steps. It requires a lot of steps and processes so that this part gets manufactured and ultimately it is delivered to the customer so that it meets the customer requirements. Hence, design is described as a set of processes that translate customer requirements into manufacturable outcomes. So basically, there are some points that are true about the design. They are, it is creative. Yes, we all agree with that, because all the time the customer requirements changes. In order to meet the changing customer requirements, the product has to be very creative. In order to make the product more creative, then the design aspect involved in creating the product must be creative. Hence, the design is always creative. It is multidisciplinary process. It is true, because nowadays a component is built up of all the many components. So it requires various engineering fields to come to manufacture a particular product. Hence, it is always true that it is a multidisciplinary process. It seems to need to be iterative. Is it true? Yes, it is true, because it is not possible always, or it is not possible most of the times, or 99% of the times, that whenever you design, the first design is taken as the final design and it will go for manufacturing. There will be certain iteratives, because there are various stakeholders that are involved and there are various departments that are involved in finalizing your design made by the designer. Hence, there is always a change in the design that goes, and after certain iteration only the design will be chosen as the final design. Hence, the design needs to be iterative. It is evolutionary. Yes, it is true. It is evolutionary, because if you look at the two-wheelers or bicycles, simple examples, if you look at the bicycles now we are using, if you see the bicycles that were used by our ancestors, there are a lot of changes. So that means the design of the bicycle has evolved. The design of the bicycle has evolved. It is true for all the components and products. So the design always keep on evolving to meet the customer requirements. Hence, the design is evolutionary. It serves human needs. That is true. Because whenever there is a need arises, that means that gives the customer requirements, and to meet the customer requirements, the manufacturer tried to build a product, and to build a product we want a design. Hence, it serves the human needs. Similar to design, quality is also defined by different people. Is that true? Yes, it is true, because a lot of people that are involved in defining the quality. Hence, it is defined by different people. In general, quality is simply, what I can say, in general, the quality is simply meeting customer requirements with respect to dimensions, with respect to aesthetic wise, with respect to design, with respect to functionality, so with respect to appearance, with respect to life, with respect to reliability. So all these things in general we say it as a quality. So meeting all these requirements means the component is meeting the quality of the design. So complexity in quality. So as I told, the high quality design, when you say the component has a high quality, when it satisfies the reliability of the component, when it satisfies the foundation, when it is quick, when it is cost, when it is less cost, when it is easily manufactured, when it is environmental friendly, when it is less weight, when it is more safety, when the little risk is involved, when it has aesthetic appearance, when it has a long duration, etc. This all builds into the high quality design. So satisfying all the requirements is not an easy task for any product. So which in turn will affect the design of the product. So considering the early changes, early case designs of a car. So you can just look at a car design. So first there are a front wheel drive front engine, and then later the front wheel drive rear engine. Now rear wheel drive front engine, and then the rear wheel drive rear engine. So composition of designs. Basically, there are two main problems in dealing with overall concept of design. Basically, there are two problems in dealing with overall concept of design. So that means, the first one is the design is very complex process, and then it is confusion. It is confusing, or you can say confusion. So design is a very complex process. Yes or no? Yes, it is a very complex process, because process in any manufacturing of any product manufacturing or product process, because finds the future steps in part manufacturing. It defines the future steps in any part manufacturing because it acts like a foundation to any product. It acts like a foundation to any product. If the foundation is not good, then obvious that the product is going to fail. Similar to your building. If the foundation of the building is very solid, then the building will be very strong and it will survive all the odds. But if the foundation of the building is not good, then the building will not be good and it will not sustain the test of time and eventually it will fall. Hence, what we can draw the conclusion from this is that the foundation has to be very solid and very defining. So, in building up of any product or in manufacturing of any product, design becomes a foundation. Hence, if the foundation is the design, then it will direct the other processes that are involved in manufacturing of the product. Hence, we need to draw various important information from all the process and needs to be incorporated in the design before finalizing the design. So that we need to take the information from the customers and then the market, then the production department, process planning department, quality department, and then the sales, and sometimes we need to even take care of the service and maintenance also. So this all consideration we need to consider in designing a product. Hence design is much more complex as it is. And then it is confusing because what happens is that as we take much and much information from the other departments or the other sources, we tend to get confused. Hence, the design is often confusing or it leads to confusion because once there are a whole lot of conceptual designs, to finalize the conceptual design among various conceptual design is a Herculean task which leads to a confusion because one conceptual design may be better than the other conceptual design in one or the other way. So we need to choose once a conceptual design which suits or which meets all the requirements compared to the other conceptual design. So deciding the conceptual design to make it the final design is a confusion. And for the design of product, firstly understand elements of design and various stages of design process. That is true. So the last line, that is, for the design of the product, firstly understand elements of design and various stages of design process. So that means for designing the product, you need to understand various elements of design. That means what are the things we need to consider in designing. That means if you are designing a building, I am just giving an example, you need to consider what is the requirement of the customer and what is the available land which needs to be built, and also in India we need to consider some vastus, and then what is the height that can be achieved and what is the cost that the customer is going to bear for that particular building, and what are the materials that we need to buy and the sources of the material and the time and availability of the raw material to build that building. So this all comes by in building of the building. Similarly, if you want to design a product, there are various elements of design that we need to consider, such as what are the different types of raw materials we require, what are the sources from which the raw material is required, will be bought, what is the quality of the raw materials that we are going to get, and what are the type of machines we need to require the particular product, and what are the tools we are going to require for manufacturing a particular product, from which vendors or suppliers we need to buy the tools, and which machines and how much the machining time will be there. Again, with respect to that, we are going to calculate the machining cost. So these all things we need to understand before designing a design for any particular product. So you can see it is very much clearly shown in this block diagram that so the design of a product must be of suitable form, and it must fit the customer requirements, and it must be fruitful or fruition. So these all things can be further be summed up by the following steps, such as defining a customer requirements. And then what means defining customer requirements? We all know that if you are going to meet the requirements of the customer by your design, then only the customer is willing to buy your product, or else he will just back off, because there are a lot of competition in the present market scenario. If you are not building, or if you are not building a product which is not meeting the customer requirements, it is obvious that the customer will not buy your product. Obviously he will shift to some other product. Obviously then you will tend to lose the customers, and then if you lose the customers, then your product will not be sold, and if your product is not sold, then there is no profit you are going to earn by the product. If you don't earn any profit, then you will be incurring the losses, and ultimately it will lead to shutting of the part. So we need to always define customer requirements and try to meet the customer requirements, and always there must be a scope for innovation. So because the customer requirements will be keep on changing, hence if you start for today's customer requirements, when the product will come into market, it will take around 2 months you consider, and after 2 months the customer requirements will be changed with respect to that particular product. Hence you need to be futuristic, and you need to be innovative to meet the customer requirements ahead of the customers. And then understand what is actually the product you are making, or what is actually you are designing for. If you understand it, what is you designing for, then you can design a good product so that it has its value when it reaches the customer hands. And then translate into drawings. This is very important. So always once you have designed a very good design, and if you are not able or capable of translating your design in the form of drawing so that it is effectively conveyed to the manufacturer, then the manufacturer can't easily manufacture the products, or can't easily manufacture the parts which are required for the products. Hence it is very much important to translate the design ideas effectively into drawings, and then translate them into manufacturing. Once you have effectively conveyed your drawings, your design in the format of drawings, then you need to convey those drawings effectively to the manufacturing. That means every manufacturer who is working for that part must easily understand the drawings that you have made. So that means you need to follow all the universal standards only. Next, every product designed contains 3 elements of design. That is true. So every product that we are designing contains these 3 elements of design. Basically, it is, first one is the form. What is form? It is the aesthetic end of the design spectrum. Totally public usually means designed by this. Today public usually means designed by this, sorry. Today public, this is very important. It may be funny, but today public usually means designed by this. The shape and appearance of the product is often regarded as the design in today's world. What is form? It is the aesthetic appearance once you look into the product. See, if I look into this product, what people say, yeah, it is good design, man. Once you look at the cars, if you have the people around it, they say that, yes, that is a good design. What is the good design actually? By seeing the external appearance, people are nowadays say that the car has the good design. But is that true? But actually it is not true, but nowadays people are considering like that itself. If it looks good aesthetically, or if it is appealing in aesthetically appealing, then the people say that the design is very good for that particular product. It is not true, but people believe that it is true nowadays, because what they see is only the aesthetic part. What they don't see is the parts that are involved inside the part. Suppose Suppose it goes through with the people also. If somebody comes always trim with good dresses and all the people in and around feels that he is very good or he's good looking, but we never know what he's going through. Consider an example of Sushant Singh Rajput. So all the people what we felt that the person is very good and he doesn't have any much more tensions because he is always fun loving, charming, smiling. But we don't know or we didn't knew that what the depression he was under. So ultimately what he ended in suiciding, giving up his life. So similarly, what looks is not what it looks will not be there. But people nowadays believe in that it holds good for the product also. The people nowadays believe that if the product is nice looking and pleasing to eyes, they feel that it has very good design. Then fit. It's a part of the design deals with how things go together, how they integrate to form the whole system. Suppose you consider an assembly or a product. You know that a product or an assembly consists of various number of sub-assemblies, and those sub-assemblies in turn consist of various number of parts which are assembled together to form a product. But whatever the parts you are manufacturing, if they don't fit properly to form the subsystem, then there is no way that this subsystem will be assembled. So that we need to take care that the part that is being manufactured must be forming a close fit. And even though if the parts are fitted together to form the sub-assemblies, if those sub-assemblies do not fit with respect to each other to form the assembly or product, then it is not possible for us to achieve the product because the sub-assemblies are not fitting. Hence, we need to always make sure that there exists a perfect fit between the parts which are making the sub-assemblies and also between the sub-assemblies which are making the product. That means the parts must be manufactured by using interchangeability and selective assembly processes. And then the function. This we had discussed with respect to the reliability when we are considering the reliability, isn't it? What is the function? This part of the design dissatisfies customers, basically. It is true. And then it is aspect of design that causes failures or poor performance of product pursued by customer as not meeting the requirements. Basically, what is the purpose of this pen and why this pen is designed and why people purchase the pen? People purchase the pen to write, isn't it? If I buy this pen today itself from one of the shops and if I come to college and when I take it, when I start writing, if it doesn't write, then obviously it is not going to satisfy me because I'll get dissatisfied by this particular product and never again in my lifetime I just go and complain it to the shopkeeper and never in my life again I'm not going to buy this because I had some important work because of which suppose you consider that you have just bought a pen yesterday and today you have the exam and suddenly you enter into the exam hall and you open the pen and you start writing but it doesn't write. Then what will be your situation or how you react to that particular pen? Say that the pen is not good, I tell you complaint about it with respect to your pens and tell not to purchase this particular product because the function of the pen is to write and it is failing its function. So basically function is nothing but function of the assembly is nothing but when parts or subsystems are assembled, it must perform its intended function. If it doesn't perform its intended function, then we obviously blame the design is not good. Yes, how this thing is very important. Forms or the aesthetic look we are talking about. Form can be measured by judgment. Yes, we can easily judge the persons or we can easily judge the cars. If the car is very good looking, we say that wow, it is a very good design. If the car is not very good looking, yeah, the car is not very good looking. Or we say directly that, so this car is not a good design. But when we say very good looking aesthetic car, whoa, the car is very good design. Yes, it is a judgmental Beauty is independent upon individual taste. That is true. It is always said that beauty is in the eye of the beholder. Beauty is independent upon individual taste. So each individual taste has different beauty. That's why whenever you see a car manufacturing nowadays, they will be having different models to suit different customer requirements, because they know that each individual choice is different with respect to the other individual. Similarly, he feels that once a people is looking at a particular thing, his views will be different compared to the other views. So it is true that if you look at among yourself, if I ask you who is your favorite heroine in Bollywood, some may say that one Deepika Padukone, some may say that Katrina Kaif, some may say that no, these are not good, I will believe only in Madhuri Dixit. So again, the perception of each individuals are different with respect to considering the beauty and the aesthetics. So something pleasure to one person may not be the pleasure to the next. That is true. Experts in industrial design may predict quite accurately whether one particular aesthetic design is more appealing to particular customer than other. So again, this is left to the experts who are designing the particular product. They must predict accurately whether one particular aesthetic design is more appealing to particular customer than other. So by deciding that, once you build a design, they need to make sure that more people are going to like the particular product aesthetically. So if the percentage is more than 50%, then obviously they'll put or they will agree to that aesthetic design. If the experts feel that less than 50% are going to like the aesthetics of that particular product, then obviously they will do certain modifications with respect to the aestheticity of the particular product. Next, fit. Fit is very easier to measure because there are a whole lot of devices which is used for measuring the fit. If it doesn't fit, then obviously there will be no particular function with associated with that product. Fit is optimum for correction and life. That is true. Fit is very much optimum for the particular correction of a particular product, and it also defines the life of the particular product. Checking fit is the primary tool for inspection facility in production environment. So basically, there are design instruments which are used to check the fit or the closeness of the fit in any particular assembly. So basically, before selecting the fit, we are going to inspect basically by using gauges. So basically, there are two types of gauges: go gauge and no go gauge. See, those go gauge and the no go gauge defines the type of fit that is going to incur in any particular product. So the go gauges and no go gauge is such that the difference between them defines the tolerance for any product. So the go gauge, as the name itself suggests, it must allow the part to pass through it. Then only it says that the part is okay and is accepted. In the no-go gauge, the scenario will be such that, as the name itself suggests, it must not allow any part to pass through this. Then only it says that the part is acceptable or else the part is rejected, because the difference between the go and no-go gauge is nothing but the tolerance. So the go and no-go gauge are basically used for selecting the fit for holes as well as the shafts. Next, the function is not easy area of design to measure. That is true. You can just predict that a particular color component is going to function through a particular period of time, but you can't exactly predict till what time the product is going to be functional, because at the time of the testing you may be separate environmental conditions, but at the time of actual performing there will be a separate environmental conditions, and also the way in which the customer is handling the particular product also defines the functions. Hence it is not easy to predict the function of any particular product, or it is not easy to measure the function. Next, problems with testing for good functional operation is that one has to build hardware and incur heavy costs. That is true. So if you want to exactly predict the functional operation, then you need to build a hardware which will incur a very heavy cost. So that is most of the companies aware that, but if the company is using that, then obviously the cost of the part is going to be very huge, because the kind of input operations they are building, they are incurring, they need to put that into the cost. Hence, the cost of the product will increase if you want to use any hardware to predict exactly the functional operation of any particular part or product. Now, industries have using simulation as an alternative to testing, which is infinitely less costly and should be pursued more. It has been using from long, like from past so many years, that simulation. What are the nowadays? There are a lot of simulation softwares like ANSYS, LS Dyna, ANSA, etc., wherein where you are going to build a product and then put the different bordering conditions and with different loads, so that we can test whether the part is going to sustain or whether the part is going to break. If the part is going to sustain that particular load, then we can define the function of that particular component. If it is not sustaining, we are going to make certain design changes so that it again meets the, again we are going to test by the new design changes, and again if it is meeting the certain requirement without any failure, then we conclude that this particular product is going to meet certain functions through a particular period of time. So basically there are 5 phases of design. There are sorry for that. There are 5 phases of design activity. Basically there are 5 phases of design activity. First one, define the requirements of the customer. Define the requirements of the customer. So that is nothing but the requirements of the customer. This is one of the most neglected elements of design. So in most like 20-30% of the people in the design usually tend to neglect the customer requirements while designing a particular product. So that is must be avoided. We need to consider the requirements while designing a design for a particular product. By doing so, product is not delivered and which satisfy the customer needs. So basically if you are not considering any customer requirements, what happens? In design, you are going to build a design with respect to your own ideas, but if you build a design with respect to your own ideas and you try to sell it to the customer asks for whom you have built. For yourself, then you take only your products. I am not interested in buying your products. That means the design is not appealing to the customers with respect to his requirements, and he will not be having any interest in say taking the particular product. Hence, it is always advisable to consider the customer requirements when designing a design for a particular product. If design team do not understand customer needs, product is delivered, but there is business failure through that. If design team does not understand the customer needs, if they are incapable of understanding the customer needs, or sometimes they tend to neglect the customer needs, then what happens? They are going to ultimately build the design, confirm the design and build the product. And once they confirm the design and manufacture the product, and when they try to sell it to the customers only, right? Because these are the things which has to be made for the customer and it has to be bought by the customers. The person who is buying, making the processes or who is making the design will not buy any products. So hence when it goes to the customers, they will not buy the products, and this will lead to the business failure, because all the products what you have been manufactured with your own design without considering any customer requirements, then you will not buy any product design. So just consider nowadays what's the trend? The trend in the cell phones is the touch screen. If you want to build a design, build a cell phone with keyboard, presenting for customers such as young generation, nobody is going to take that. But if the designer is adamant that I am interested in only using the cell phones without any touch screen, I will make this product only, but I will not consider the youth generation. I don't care about the requirements, but the requirement for me is to build a cell phone with the keyboard without any touch screen. And if we approve the design, and if we manufacture, and if we product, and if we try to sell to the youth, then obviously they say that, boss, I'm not interested. So then what happens? The lot of products that have been manufactured that has incurred a lot of costs associated with that. Hence, those costs will be a burden and the business is going to fail. Customer requirements can be established by market research, looking at what competition is going on and by getting feedback from field of existing products. So basically, how you define the customer requirements? By making a market survey, and looking what is going on in the market for that particular product and what is the competition for that particular product, and taking the feedback from the existing product. Suppose you want to come up with a new cell phone in the market. So what we need to do? We need to have an extensive market survey, and there will be some good brands. Suppose you want to enter into the mid-mobile segment or mid-segment mobiles, and if you want to make a high-segment mobile, you consider which are the top sellers in those segments and just take the feedback of the customers who are using that. And if there any variations or they desire from that particular product, that also needs to take, and that will define you the customer requirements for your building up of the product. So basically, it can be done by any method. It can be done by taking a whole lot of sample and then investigating them, or it can be done by one-on-one personal interviews, and it can be noticed. It can be done by just by observing also. But by observing just the people who are using the cell phones, you are not going to get much idea about the requirements of the customers. Hence, a lot of group has to be investigated, interviewed. I suppose the personal interviews are better in this, and in personal interviews you need to interview the persons who are actually using the products. Here in this case, I am talking about the example of the cell phones. If you want to enter into the cell phone market, in the mid-range cell phone market, according to me, the leaders nowadays are the Samsung and MI or Xiaomi. So you need to look into the customers who are actually using that cell phones, using the cell phones, and you need to take the feedback from their particular customers. Suppose if you want to build any mechanical product, you need to take the feedback from the customers who are actually using that product in a working environment. Then only you are going to see as well how the part is behaving, and also with addition that you can have an interview with the customer who are using that particular part, and then you may have a rough idea of shortcomings of that product, which will make the plus points for your product building, and also what are the good points of that particular product. So you need to at least meet the good points of the existing product, and the shortcomings, if you want to have an edge, you need to also meet the shortcomings of that particular product, and all those things you need to incorporate in your design and trying to fulfill all the points. Then only your product is going to be a huge hit with respect to customers. Then generate ideas by innovation. So basically, this is done by any brainstorming session or one-on-one interactions, so that the new ideas is always generated which will help or enhance the design of a particular product. That means this is one area of design that most people recognize as the key element. That is true. Choosing best way to innovate can help to improve results. As if you are done, or if you are giving the innovative design product to the customer, then obviously they are going to buy this. Then understand the function. Basically, this is very important. So here one method is established to implement design, the next step we go for its function. Once the design is implemented, or once we feel that the method of design is good, then next what we need to concentrate is the functionality of that particular product. The output of the function and failure modes are studied. So basically what is the output of that particular product, or what the customer is expecting from that, and what will be the failure mode for that particular product. That is FMEA of that particular product we need to study. And if this element of the design is not fully carried out, then make sure that performance criteria are met, which is done by testing hardware. So obviously we need to test the component when it is done with manufacturing by using the hardware testing. Next, understand function properly in the first place is nothing but the major benefit to subsequent steps in design, as it eliminates repeated iteration of hardware to implement changes. So basically this we had discussed in when you are comparing with the concurrent engineering with the sequential engineering. So what happens in concurrent engineering and sequential engineering, if you have still in mind, that I will explain. In sequential engineering, what happens is, what used to happen is that when there will be different departments in building up of a product, so there will be, like, I'll consider just some departments like marketing survey department, and then design department, production department, quality department, sales and service and maintenance department. Okay, we'll just consider this department. Whenever the customer survey departments makes the customer survey, and then in sequential engineering I'm talking about. So when they make the customer survey, they'll pass on these ideas to the design. So they'll advise that these are the survey results what you have made. So you can incorporate this in your design by making the requirements of the product. So designer take those information that is passed by the market survey department, and then those points he'll incorporate and make them as the design requirements, and then depending upon that he's going to build the design, and after building the design he's just going to convert those into the 2D drawings, and then he's going to pass it to the production department. And in production department what happens is that he's going to start producing the parts. After producing like 10-15 parts or 100-200 parts, he suddenly noticed that there is the change in the design that has to be made. There is a change in the design that has to be made, and then he immediately goes back to the design department and he suggests the changes. So then those changes are incorporated by the design, and then he makes the necessary corrections in the design, and then he passes the drawings again back to the production department. But when the production department comes to know the shortcomings of the design after manufacturing 200 parts, so this 200 parts is a complete waste and a loss that is incurred, and which has to be associated with the entire cost of the product. So that means this loss will ultimately lead to increase in the price of the particular product. So then coming back, so again after incorporating the changes, yes, design production manager looks at the changes, whether the necessary changes has been made correctly or not. If it is made correctly, again he will proceed with the production. If it is not made correctly, he will send back the necessary changes again for the design department. But once he approves the design changes, then again production department start producing the parts. After producing the parts, they will be sent into the quality and inspection department. So when it is sent in the quality and inspection department, suddenly he feels that the parts are not meeting the customer requirements, or it is not meeting the specifications that is produced by the customers. Then what happens? Whatever he then suggests the changes in the production department, then the production department, they can't change any design. Hence they take those inspected part, the error or with error and then the drawings to the design department, and then he suggests the changes to the design. So again, design department, what happens is that they need do the changes and then they'll release the final drawing. So again, what happened? A lot of part that has been manufactured in lots are waste and is scrapped. So that is a huge loss that has been incurred to any industry who is manufacturing that particular part. So that loss again has to be shown somewhere, and to minimize the loss, what happens is that they are going to increase the price of the product. And in the meantime, what happens is that in the first step itself, the issue is not solved. Hence, it involved a lot of steps in defining the function of the particular product. Hence, there are a lot of changes because of which there will be a delay in releasing the part to the customer. But if in concurrent engineering, what happens is that initially before finalizing the design itself, they call all the heads of the people of various departments and they'll discuss the design with each and individual steps or each and individual department heads and some of the people of the each and individual department. Then there only they will suggest the changes with respect to the facility that is available in each of the department, and then those changes are incorporated at that moment itself, that is in the first design phase itself, and then later there will be no further design changes. Hence the part will be manufactured very quickly without any loss or without any wastage of the material. It will be delivered to the product in very quick time. Hence there will be a lot of saving of time and also the better understanding of the component without any much design changes. So hence understanding function properly in the first place itself is a major benefit to subsequent steps in design, as it eliminates repeated iterations of hardware to implement changes. So the next is the translate design into drawings or design life. So as I told, once you have finally designed the final design out of the conceptual designs, then you need to convey your design ideas to the manufacturer. The conveying of the ideas is basically done by using the drawings. In theory, drawings are not relevant to the design process, but it is false, it is relevant. Production of drawings is simply a translation of ideas of innovative designer into something that can be read by the others. Yes, you need to convey your ideas or the drawings in such a way that it must be read by all the manufacturing department who is working on that particular product. If you are failing to convey your ideas to each and every individual who is working on that part on the shop floor, then it is obvious that he will not understand any drawings, or else what he is going to do then? He is going to manufacture the part without understanding the drawings. If he does that, then what happens? He will manufacture with respect to wrong dimensions, which will ultimately result in the scrapping of that component, or else what is the other option he can do? He will just sit idle. So in both the ways, in the first way, if he manufacture according to his understanding, then he will obviously tend to manufacture the wrong dimensions, which will result in a scrap or rework. If he doesn't understand, if he just sit quiet, then there will be a delay in the production. So it is always make sure that the drawings or the ideas of the innovation, what you are trying to convey, must be very clear and must be understandable by each and every individual who is working on that particular product on the shop floor. Next, many people think that process for producing the drawings is the design, and that is the only real element of design. Many people think that process of producing the drawings is the design and that is the only final real element of design. I don't think so that is true, because that is only one part of the design. That is, we call it as a modeling and drafting. That is not the entire design, what we call. It is just the one part of the design. Nowadays, basically the engineers are doing the same thing. Just they are going in the office, sitting and just modeling and releasing the drawings. But they say that they are design engineers. No, they are not the design engineers. They are the modelers and the drafters. There is a lot of difference between the modeler and the drafters and actual design engineers. So the design engineers take care all the accountable steps what we had discussed, but the modeler and the drafter only conveys the ideas given by the designer to the manufacturer. So he is not called as a designer, he is called as a modeler or a drafter, remember. And then design is good or bad according to what goes into drawings, not the drawings themselves. That is true. This statement only makes the difference between the modeler and the designer. So design is good or bad according to what goes into drawings, not the drawings themselves. So the modeler or the drafter only make the drawings. But who is giving the inputs for the modeler or the designer? It is the design engineer. So that is the difference between a design engineer and modeler and the drafter. So we'll continue the remaining